Greetings, greetings, greetings. This is video number 2 of chapter 11 for Kinesiology 236. We're talking about the trunk and spinal column. And moving on from this slide, when we talk about the ribs, you have 12 pair of ribs. And the best way to think of it is if you break it out into this color codification here. You have 7 pair of true ribs that are attached on the sternum, including the manubrium, which is part of the sternal complex, but they attach there and they originate back in the spine. And think of it like almost like hands coming around your body, and those are the fingers, and they attach to the sternum. It provides a nice beefy rib cage to protect all the vital organs inside, and it provides great structure as well, as I mentioned earlier in the previous lecture. You have 5 pair of false ribs, those are denoted in blue, and they originate on the spine, but they don't attach to the sternum. They actually attach to, so here, this material here. Okay, so it's not a direct attachment into the sternum, it's actually down here. And when you look at this and you go, okay, it's still kind of attached. It's on the costal cartilage, but it's not on the actual sternum itself. So it provides some structure, but not as much as up here. But you'll notice all the important stuff, all the vital organs that are super important are all up in here. If we go a step further and we look at the next layer, you have the floating ribs, put your fingers in quotes there, and those ribs themselves, they are on the spinal column. They protect on the backside, but they don't wrap fully around the body. And if you look at this, everything is attached to the thoracic on the posterior side, but on the front side, it's not. And boy, if that's a test question, if I've ever heard it, I don't know. All the ribs in the body attach both to the posterior, or attach posteriorly to the thoracic vertebrae, but they also attach to the sternum. That'd be false, because some are floaters and some attach out here to the costal cartilage. So that has test question written all over it. Bony landmarks, I left this in here. You really don't have to focus too much on it, but it might be good for you to know some of these as you go forward. I'm gonna go ahead and leave this up for a second for you to marinate on them real quick. Okay. Now as we jump into the craniovertebral joint, or atlanto-occipital. Now this, if you look at this, atlanto, remember you had axis and atlas. Those were your 2 first vertebrae. And the occipital part of the statement or word is the part of the skull, the bottom part of the skull, right? The articular fossa that is here on atlas articulates with this part of the skull right here in red. And so this craniovertebral, vertebral vertebrae joint, or atlanto, meaning atlas, and occipital, which are the occipital lobes. If you think of occipital lobe in the back of the skull and the brain itself, you can articulate where this is. And so the skull pivots, as I mentioned earlier, about the dens, which is this guy right here, and this is a really good shot of this kind of tongue and groove setup that they have between axis and atlas, where axis C2 has the dens that pops up in between atlas, and this is what the skull sits on, the articular fossa, and this is what the skull rotates about, the dens. And boy, if that isn't a question, I don't know what isn't, right? So you have to know the difference between atlas and axis and how the skull articulates and what the skull rests upon. So be on the lookout for that as a question. Let's take this a little bit further. The atlantoaxial joint, so that's now the joint between atlas and axis, right? Atlanto, so that's your atlas. Axial is axis, and that's C1 and C2. So if we look back one slide, that's literally this joint right here between C1 and C2. And that's, again, you can probably dream up a test question regarding atlantioaxial and atlantio-occipital and the differences between those two. Just saying. Good, good. All right, go ahead and breeze through this. All right, so when we look at the spine, I said this earlier, when you look at the amount of movement that's available in the entire spinal column, it's great. But the actual movement between 2 particular vertebrae is quite small unless we're talking about that atlantoaxial joint, right? So you have axis and atlas, the way they articulate with the occipital part of the cranium you have this articulation that allows, just think of this as you're turning your head from side to side while I'm lecturing, you can go through a range of motion between those two main joints, that being atlas and the skull, and then atlas and axis, and you can get an idea of how much mobility you have there. It's less level to level to level in the vertebrae. Okay. The book notes that the vertebrae themselves are a gliding type of joint, and I agree with that, and the way they articulate is fine. I'll ask you what type of joint that is, and you may recall way back from chapter 1 what type of joint that is. I'm not going to give that away here. I'm going to force you to go back to 1 and look. All right. Now, with the vertebral column itself, it's not just bone stacked on top of bone. You do have material in between, and that material is there to cushion and allow for articulation. And those are referred to as discs themselves. The discs themselves they're not like filled with water. Think of it like a balloon filled with jelly, right? So when you're moving and articulating, it's not instantaneous like if you were to squish a racquetball or squish a tennis ball or squish water. There's actually a little bit of latency in there. So when you do exercise, you have to be aware of this, right? Now, there is a nucleus, the main part, and there is this kind of fibrous material on the outside of it. And when you look at this kind of fibrous material, when people have difficulty with a disc, usually it's that fibrous material that has given way through injury, through overuse, etc., and you end up having either a protrusion, a bulge, or a full-on blown-out disc that has to be replaced, or the vertebrae have to be fused, which takes us back to our mobility conversation earlier. So I put in a couple different views of this so you can see it. One with this where you can kind of see they took away the vertebrae on top and you can see the entire disc itself with the nucleus in the middle. You can see this one in more of like an analog version, kind of a model of a skeleton where you have the vertebrae itself, you have the nerves themselves, and you also have the disc material. Take a look at the vertebrae here. Maybe you can start picking out what kind of vertebrae it is with the bony processes in the back, just saying. And with the discs themselves, that protrusion, when it comes out, it can put pressure on a nerve root, right? So sciatica, somebody has an issue in L5-S1 and it rubs on this nerve root, that then takes the nerve root, the irritation, and it aggravates everything else downstream. So somebody who presents with like maybe numbness or tingling in their foot, they actually might have an L5-S1 issue, or maybe S1, S2, depending where they feel in their foot, because the herniated disc is actually rubbing upon the nerve root itself. So realize your culprit, your root cause could be further up in the spine as opposed to something further down in the leg. But this is pretty common, this type of injury. I have to admit, I've seen a number of those in my career. So I put this video in to kind of help you visually see this, right? And let me go ahead and play this, and I'll play while I'm talking. I've used 2 coffee mugs. Here's the spiny process of the vertebrae. It's the posterior aspect. This is the anterior aspect. This is the nucleus itself. This is the, that's the disc. We're lining up the vertebrae. So now look at this. Oops, that's my chew toy. Sorry, my dogs are freaking out right now. As you squish that down and you now go anterior to posterior, notice what happens. The material gets squished on the front side or the back side or side to side, or when you rotate. What happens here? So I'm going to go back to this. You can see when there's tilt to the front, anterior tilt, this gets smaller, this gets bigger. So when somebody blows out a disc, it's usually because that material has not been able to move fast enough and squirts out one side in between the vertebrae. So you can just think of this, right? Tilting forward, squish, everything gets pushed to the backside. It's like a pie shape. Let's do it one more time. Rotate, or lateral, lateral, and now we'll rotate around. And rotate as if we're doing some type of twist. So you can just imagine that material, right, in between the 2 vertebrae, how much of a demand that has on it. How those discs have to respond through different exercises, through different levels of the body. Just kind of think that through as you're working out and doing exercise. It's a bunch. And let me go to the next one. So they broke this out in a book, and I thought this was pretty darn confusing the way they did it. They ended up listing stuff, and they listed it. They listed like the cervical stuff last and the other stuff first. I'm like, well, if we're talking from top to bottom, let's put the cervical stuff first. So this will look different than the original slides you saw in your book. And I did this deliberately so now you have kind of a top down as we go through these slides. They're talking about the first cervical vertebrae within the actual vertebral column, right? And again, we talked about atlas and axis. We know vertebrae 1, vertebrae 2 in the cervical region and the entire spine, and they articulate with the base of the skull. You know one of them, axis, has a pivot point. Atlas, like the guy who holds up the earth, holds up the world, he actually supports the cranium. And then when you look at this and you go, okay, with spinal cord movements, they occur in the cervical and lumbar regions, you kind of know this, right? Because as we talked about earlier, all those thoracic vertebrae, they attach to the ribs up front, and I'm sorry, to the sternum up front via the ribs. And just think about the amount of structure that provides. So if there's one thing we've talked about in this class a couple times, it's you have mobility stability. So that thoracic area has a ton of stability, but as a result, it doesn't have as much mobility. Conversely, when you look at atlas and axis, which we talked about earlier, there isn't a lot of stability, but there's a ton of mobility in that joint. And same thing when you go down further into the lumbar region of the back. The difference and the challenge you have there is when you have this much mobility in the neck and you have a bunch of mobility in the lumbar area, you have now a predisposition to injury, right? Because you just don't have the stability there to hold the spine in place while doing exercise. So specific to spinal loading, put your fingers in quotes, you look at some of the movement patterns, you just have to be smart about trunk flexion, trunk extension, anything you do with the neck, because those are really the weak areas. When I see people try to roll out their neck using a foam roller, or they try to roll out their back and they're rolling out the lumbar region of their back on a foam roller, that's like the weak link in the whole process. Unless you're highly skilled at using that as a tool, you just don't place your entire body weight on the lumbar region and roll out. You have somebody else do that for you while you're lying prone on the table, because you're really putting yourself at risk for a lumbar injury. And same thing, we'll go into just lumbar mobility. You can see there's a ton of mobility there in the lumbar region. All right. This I left in. I thought this was good. It kind of gives you a little bit of a synopsis of how things are named. Flexion of the trunk at the lumbar spine is known as lumbar flexion, which we've used that kind of colloquially in class, but these are, when you look at verbiage, it's good to kind of put that together and have that in your hip pocket. I left these in, and spinal flexion, and you have lumbar flexion, right? So chin going down to the manubrium, and then the bottom one, a lumbar flexion, she's bending herself on over, elbows to knees. All right. Pay attention to, as she's doing cervical and capital flexion, atlas and axis, and think about the vertebral column. Think about those vertebrae in the cervical area. Now think to the coffee mugs with the little squished doggy toy in the middle. As she's going forward, she's smushing the front part of her coffee mugs together, her vertebrae, and she's smushing that disc. And so the disc material has to go posterior on that cervical flexion. Down she goes. So you look at this and you go, all right, a couple things have to happen. Yes, the movement pattern is cervical and capital flexion, but that anterior movement will also bring a little bit of anterior glide from 1 to 2 to 3 to 4 to 5 to 6 to 7. And then we've talked about this in length with people who sit at computers all day, but realize cervical flexion requires articulation of several joints. And even with that, the thoracic area is pretty stable, but you still see a little bit of movement and articulation in here. You almost can't help it. Now with lumbar flexion, she's staying pretty neutral in the neck, but I'm going to say it again. She's got lumbar flexion, but she's also putting in, let me get it here, you can see she has a lordosis. Hold on, guys. I got to pause the video.